So yeah, so I will talk about operation stratification, and I think the main one big difference with Matt's talk is that we've got sparse observation here, or one difference to the SST and SSH, and so basically it's a very hard task to try to assess the state of climate of operation stratification because of the sparse observation, also because of the high variability, very high variability of the operation. But still, I think that's a very important question for many reasons. I listed a few of them. That's closing the overturning circulation is very important for heat and carbon storage and for biology. And so that's a really hard task, but that's important. So I think we should try to see what we can do. And so if we want to see what we can do, we first thing to look at is what observation do we have access to? Do we have enough observation to create a robust climatology? And here we want a seasonal cycle. We want to resolve the seasonal cycle because the operation seasonal cycle is so strong that anything climate relevant will be away from the seasonal cycle. And finally, the question that we really want to ask is how do we compute anomalies, or how do we assess the climate? So let's start with the observation. So in the Southern Ocean, we don't have many observations, but I think we have to realize that we are fairly lucky to have very complementary data sets. So the first data set that we have access to is the ship-based hydrography. And so here I've got a few plots showing the number of observation per year, number of observation per month, and the number of observation per latitude band. And so what we can see is that the ship-based hydrography basically started around the 60s. There was a peak around the 90s. It's a bit of a drop. I think I haven't updated my climatology here, but yeah. But there's definitely a peak around the 90s. This ship-based hydrography database is summer biased, so there is more observation in summer than in winter, and it's also slightly biased to a lower latitude, but there's a good coverage of the latitude bands of the Southern Ocean. Along with the ship-based hydrography database, we've got access to the Argo database, which really kicked off in 2002 in the Southern Ocean. The strong advantage of the Argo dataset is it's not seasonally biased. So there's as many observations in summer than in winter, and also it fills the gyres. The subtropical gyres. So you see the very good number of observations between 40 and 60, basically. One of the main drawbacks is that you've got no observation of south of the ACC, mostly because of the presence of sea ice for most of the year. Then the third observation system that we have access to is the SEALS CTD database. And so that's a very large number of observations starting in 2004, approximately. That's slightly biased in season. There's more observation in fall, basically, but that covers all season. And the main advantage is it covers the region south of the ACC. So it really fills the region that we didn't have access to before. So I think I like this plot because it really shows the complementarity between the three datasets. Another way to have a look at this complementary is to look at maps of number of observations. So here we've got in color the number of observations per 2-degree bin. So in the upper panels we've got summer and winter in the bottom panels, and we've got ship, Argo, and SEALS. And so basically the same story as I just said. You've got the ships that are mostly around the coast and along the coastline. You've got the Argo that fills the middle of the gyres, and the SEALS concentrated south of the ACC. So we've got a good complementary system of observation. So I think as physical oceanographer, we are used to the ship and Argo observation, especially to look at mixed layer depth. We are not too used to the SEALS observation, so I think it's worth stopping just for a minute here to see if we can use the SEALS observation to detect mixed layer depth. So yeah, I just want to acknowledge very quickly the great work done by Fabien Roquet at the University of Stockholm. So basically what he does is takes all the datasets from different groups around the world and post-process them consistently So he does like a great quality control job, and a consistent one, which is really nice. And basically, Fabian tells us that the error in temperature is about few 10 to the minus 2, and error in salinity is a few 10 to the minus 2 as well. So the error of the SEALS observation are quite large, which might be an issue when you try to detect a long-term trend in temperature and salinity. But when you look at mixed layer depth, it's a bit different. So you've got a very strong stratification. So I think you can look at mixed layer depth with this observation. I think the main problem is the poor vertical resolution. Basically, you've got 15 points per profile. Here I've got one example of a profile. And so what we decided to do is to use different methods to detect mixed layer depth, and basically say we have a reliable mixed layer depth when different methods agree together. And that's quite conservative. We reject a lot of profile, but we still keep 70% of the database, which is 200,000 profiles. So that's a lot of profiles. And then we assess the error as basically the vertical resolution around the found mixed layer depth. And that's actually fairly good, much better than what I expected. It's around 10 to 20 meters for most profiles. So we've got these three database, and so next question is, do we have enough observation for robust seasonal climatology? Whatever means robust, I'm not sure. So here I've got so number of observation for the combined data set for different months of the year. And so I would say that we've got enough observation for robust. We could discuss that for hours, but I think we've got fairly good coverage, and we can resolve the seasonal cycle here. So then the question is, if we create a climatology out of this combined data set, what does it represent in terms of year of the representation of this data set? So here I've got plots for the median year of represented by the ship observation that's in latitude. So basically, with the ship observation, we represent climatology centered around the 80s or the 90s. For the Argo, you mostly around the 2010, and for SEALS, same. And so when you have a combined data set, you've got a fairly inconsistent representation of the climatological year. And you can see that on a map as well. So you've got here the median year on a map for winter and summer. So you see that for most of the basin, you've got years around 2010, 2005, 2010, depends. And for coast and around the coast, you've got mostly around the 90s because of the ship observation. And so for to have a consistent climatology, what we decided to do is to downweight the historical data to try to have a climatology representing the year 2010, the decade 2010. Now, so that's the median year, and how long is the period represented by your climatology? You can have a look at that by so here I'm showing the percentile 90 minus the percentile 10 of the year distribution. And so that's the unit is number of years represented by your data set around the median, basically. And so what we see is that in summer, for most part of the Southern Ocean, that's around 5 to 10 years. And in winter, we've got south of the ICC in winter, that's mostly around maybe 1-2 years. So that's not a lot, basically. So I would say that we represent the decade 2000-2010, which might not be true south of the ICC in winter, but that's so now, so we can create climatology now, and so that's what we've done with violent pressure, and that's climatology of mixed layer depth here. So we do resolve the seasonal cycle quite nicely. We can look at salinity as well. I like salinity because you see this development of high salinity tongue in winter south of the ICC. When you zoom in winter, you see very nicely the the sea ice formation with this tongue of ice salinity around the continent. And in the Weddell Sea, you even see local regional circulation patterns with this northward branch around the Sandwich Islands. So you do see a lot of things, especially because of the SEALS observations. So I think there's a lot of value in these SEALS observations. We've got this climatology, but now how do we assess the climate? I think that's the difficult question now. So there's different way we could think of assessing the climate. First one is to take long-term trend from collocated observation. So we've got this ship observation mostly centered around the 80s, 90s, and then we've got this new observation. So we could look at long-term trends. We can composite anomaly during particular climate events, so SAM events or particular sea ice distribution events. Or we could do what we've tried to do in this BAMS paper, try to look at annual anomalies. So a few examples of our long-term trend. I've tried to do that with a geographical approach on the left panel, and you see some patterns. It's not very clear. You see some trend. I'm not sure if I believe them. Then you've got, I've tried also water mass approach, so I'm doing exactly the same thing in a temperature salinity approach, and you see a much clearer pattern here with a deepening of the mixed layer in the mud water area. Again, I've done that a few years ago actually. I'm not sure what to do with that. I need to work more to really believe it, but that's one approach. It's very hard well, I'm saying that I'm not sure what to do with it because there's very few observation, and there's very high chance to alias the signal because it's really hard to convince ourselves that there is something valuable there. But that's one first approach. The other approach I've looked at is a composite anomaly during particular events. So we've done that with Steve. Looking at, so basically we take all the anomalies mixed layer value in positive SAM event and negative SAM event, and then average them together. And so we've got this map, and we can relate that to heat flux anomaly and wind anomaly. But so we've done that with SAM, but we could do it with other climate indices like particular sea ice events or polynias events. And finally, the third one, what we've tried to do in the BAMS, is to have annual anomalies. And so that's one result. So that's for the MLD anomaly for 2014. And so that's for the different seasons in 2014. And it's very hard to make sense of this anomaly. Are we looking at only noise, aliasing signal, or are we looking at something of climate relevance? I think the only way to go forward is to try to look for spatial patterns of this spatial correlation. So Steve comments on previous talk, basically. And so I think I can convince myself, I try to convince the reviewer that there is some spatial pattern there. Especially in the Pacific sector, in summer and in fall, and I think it stays in winter as well. This shallowing pattern, and the other way to try to convince ourselves is to relate that to particular heat flux or forcing anomalies. I haven't done that, but I think that's probably the way forward if we want to continue this route. So I think we need to have an integrated approach with anomaly of the forcing. So in conclusion, so I think we've got very complementary data set, which is great. We've got a good monthly coverage. We've got data south of the ACC with the SEALS observation. And every year we've got 60,000 new profiles. So we can start to look at mixed layer anomaly on an annual basis, I think, but really hard to make sense of them. And so we need to integrate the approach with forcing. So I think we do have a robust seasonal climatology, but that's only for 2010, and that's not really robust south of the ACC in winter. So it's really hard to talk about climate trend, and that's more about annual anomalies. Like we can say this is different from the previous year, but it's very hard to say that's a climate trend. And the easy part, we all agree about on that. We need to continue building, consolidating data sets for robust climatology, and especially south of JCC, especially in the Ross Sea, I think, where we lack observation. Thank you.
Thanks, JB. Have we got any questions? Since everyone's sticking to time. Just wait for the microphone.
You had that climatology, mixed layer climatology from 2010, and now you kind of made up a new one with more data. Have you learned something from the difference between the two?
Sorry?
Have you learned something from the difference between the two climatologies, the one that you had in the past and now this more complete one? Is there anything
so the one I had in the past was with Argo and ship-based, so that was mostly represented still the decade 2000, 2010, I think, and the new one that that's with the SEALS observation. That's so what we learn is basically everything south of the ACC that we didn't really believe before, and we couldn't really tell much about south of the ACC basically before. So that's the main difference between the two. I think so. One thing I haven't done is to look at the difference between a ship-only climatology and Argo SEALS climatology, where you could possibly see a trend, a long-term trend. But the ship observation, there's a lot of regions that are not covered. So, yeah.
I guess I just want to comment on this annual mixed layer depth anomaly. It seems like a kind of a quirky variable to be looking at. One, because the mixed layer depth can vary dramatically over the seasonal cycle, so comparing the mixed layer depth anomaly in the wintertime to the summertime could be dramatically different. And then from a kind of more physical perspective, I might be interested in the mixed layer depth in the summertime because it controls the biological production through light. And I might be interested in the mixed layer depth, the maximum mixed layer depth in the wintertime because it's really linked to the subduction of water masses. So I don't have an answer to the question, but it seems to me just looking at the annual anomaly is not that physical and fraught with complications because of that seasonal mixed layer depth.
Yeah, but so we look at the seasonal anomaly. So that's one way to answer your question. So we look at the
versus a mixed layer depth in the summertime that could be 30 meters and it could change by 1. So it's still kind of like a nonlinear comparison.
Yeah. So you said that we should look at percentage of change, or?
Say that again?
We should look at percentage of change, that's what you said?
I'm not sure what the answer is, but I think from a physical standpoint, I might be interested in the mixed layer depths in the wintertime and the maximum mixed layer depth because that's really linked to subduction of a water mass.
Yeah. But we do look at the anomaly like this anomaly per month, and the anomaly from the seasonal cycle. So I think we do look at what you're talking about. But so the question is, do we want to look at mixed layer depth at all? I think that's, I don't know. I'm not sure. Because the mixed layer that's not a well-defined quantity, basically. So when the stratification is weak, it can be very sensitive, and I don't know. That's open question.
In any one location, is the seal data very biased by season? As the seals move back and forth, are we really getting? You showed that most of the data is in the autumn, but in any one location, does there tend to be coverage through the year?
I don't have here the map for seals only, but I showed you this. So that's all observation combined. So I'm not sure if there's definitely a bias in season. There's much more observation in the first 6 months of the year, and so you've got south of the ACC, you've got much less coverage in the from July to December. But yeah. So there's a seasonal bias.
Okay, does anyone have any, still got time for one more question? Seb?
Thanks, Jerry. I know even MLD is a difficult variable to quantify in terms of these climatologies and trends, but will you anticipate to actually start looking at the vertical stratification and the actual magnitude of the stratification and how that might be weakening or strengthening in certain areas?
So we do look at that. So I think stratification is a very interesting quantity to look at. And the seasonal cycle, like even not looking at long-term trends, the seasonal cycle of stratification you learn a lot, like looking at difference between south of GCC and north of GCC, like very different dynamics. And so we definitely we are looking at seasonal cycle of stratification, and we plan to look at the long-term change, or as much as we can.
Okay, thanks, JB.